So 1 plus x divided by 1 minus x is greater than or equal to 2 minus x divided by 2 plus x. Now friends, we're going to take this the other side. If you want, you can take also the other one the other side, but better take the one on the right hand side to the left hand side. So what you're going to have is 1 plus x divided by 1 minus x. So if we take this the other side, the ones which are on top, the sign will be changing. So this will be positive, this is positive 2, it will become a negative 2. And then this is a negative x, it will become positive x. And then divided by 2 plus x, and that is going to be greater than or equal to 0. From here, merge as a single fraction. So I'll multiply what is on top of the first fraction with what is down the second fraction. Okay, so how are we going to do that? Multiply what is on top of the first fraction with what is down the second fraction. So I'll say 1 multiplied by 2, that is going to give us a positive 2. And then 1 multiplied by x, that will give us positive x. And then x multiplied by 2, that is going to be positive 2x. X multiplied by x, that will be x squared. And then multiply what is on top of the second fraction with what is down the first fraction. So this is a negative 2 multiplied by 1, that is going to be a negative 2. Negative 2 multiplied by negative x, that will be positive 2x. And then x multiplied by 1, that would be x. And then x multiplied by negative x, that would be negative x squared. And then also multiply the two denominators. That will be 1 minus x, 2 plus x is greater than or equal to 0. Now you can see that this is positive x squared. This is negative x squared. What happens? They cancel out. This is a positive 2. This is a negative 2. What happens? They also cancel out. Okay, and then you have got x plus 2x, which is 3x, plus 2x, 5x, plus x, 6x. So that is going to give us 6x divided by 1 minus x, and then 2 plus x. That will be greater than or equal to 0. At this point, equate everything you can see to 0. Start with what is on top, the 6x, equate it to 0. So 6x is equal to 0, meaning that x is equal to 0 if you divide both sides by 6. And then equate also the 1 minus x to 0. So 1 minus x is equal to 0, meaning that if you take x to the other side, x is going to be equal to 1. And then equate the 2 plus x to 0, you are going to find that x is equal to negative 2. After finding these solutions, I'm now going to write a number line. So I've got 3 factors. So I'm going to write 3 lines. 1, 2 there, and then the third one where I'm going to put those x values. And then those factors are equated to 0. I need also to write where I'm going to put them. Okay, so the first factor that we equated to 0 was 6x. The next one we equated to 0 was 1 minus x. The other one we equated to 0 was 2 plus x. If you look at the values that we found, the smallest we have is negative 2, followed by 0, and then positive 1. Please write them in increasing order. Don't confuse anything. So when we equated 6x to 0, we found x being equal to 0. So if you use any value greater than 0, like a 1 we put here, to be positive, right? So it will be positive. Immediately you cross the 0, put where there is 6x. The signs will change because 0 is the demarcation of signs for 6x. 1 minus x equated to 0, we found positive 1. What happens if I use values of x greater than positive 1, like a 2? Put a 2 here. 1 minus 2 is negative. So meaning that immediately I cross the 1, the signs change. They will now be positive. When I equated 2 plus x to 0, I found negative 2. What happens if I use values of x greater than negative 2? Like a negative 1 or a 0 or a 1. Try here, put 0 here. 2 plus 0 is 2 and is positive. And that it will be positive for all values of x greater than negative 2. Immediately I cross negative 2, it will be negative. Now remember, we are dividing the quotient on top with the 1. The factor on top with the 1 down. So we're also interested in the quotient.
Time.
Yes.
Hapo paragraph ambamo nafasi tuwekenzea jama kuno.
Okay, so all you are doing is you are just trying to see how the signs are going to be behaving. For 6x, if you get a value, like when you equate 6x to 0, find 0. Get any value greater than 0, you put in 6x to be positive. So that's why it's given it as positive. Anything below 0, it will be negative. Same with the 1 minus x. When you equated it to 0, you found 1. If you get any value greater than 1, like a 2, put here. 1 minus 2 will be negative. That's the negative you are seeing. And 1 is a demarcation of signs. That means immediately you cross 1, the signs are going to be positive. So same with the 2 plus x. When you equated 2 plus x to 0, found negative 2. When you use any value of x greater than negative 2, like a negative 1 or a 0, a 1 or a 2, a 3, put here 3. 2 plus 3 is 5, is positive. So immediately, as long as you are greater than negative 2, you always find positive. So immediately you cross negative 2, you'll be negative because negative 2 is the demarcation of signs for that factor. So now you're interested in the question because we're dividing this with this. Negative times positive times negative, that will be positive. Positive, positive, negative, negative. Positive, 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 positive. Positive, negative, positive, negative. Actually, you just need to know that the signs alternate. Positive, negative, positive, like that. Now here we're interested where the function is greater than or equal to. So greater than or equal to where the function is positive. Okay. It is here. Now I'm going to shade. Why am I shading? Because it is greater than or equal to. So I shade there, and then also between here I'm going to shade going up to here. So if it was just greater than, I wouldn't have shaded because we are not including. Now even if it was greater than or equal to, for rational functions the denominator cannot be equal to 0. So when you equated 2 plus x to 0, found negative 2. So the function cannot be equal to negative 2. And then you had also 1 minus x, you found 1. So the function cannot be equal to 1. So this tells you that even if it is greater than or equal to, but 1 and negative 2, they can't be included in the solutions. So where there is 1, I can't shade, I'll put open circle. Where there is negative 2, I also can't shade, but 0 can be included, so I'm going to shade. Okay, I'm going to now join these because that's where it's positive, and then this side is also positive. So meaning that the solution set for this question is from negative infinity up to negative 2, like that. And then union from 0 up to 1. But you can see that 0 is shaded, so you use a closed interval bracket, a square bracket. And then at 1 is open, so you use a curved bracket like that.